Hello everyone, welcome back to my channel. It's me Abhay. So today we are going to be starting the new series which is kinematics. And in this video we are going to be dealing with the basics of kinematics. So without any further ado, let us get into this video. So what and all are we going to learn in this chapter? Let us see. First, we will learn why do we need kinematics. So introduction, by introduction what do I mean? I mean I'm going to talk about why do we need kinematics and why do we study this chapter. And next we will be dealing with some of the basic definitions like distance and displacement, speed, velocity, acceleration, momentum, free fall, uniform motion, and non-uniform motion. So I will be dealing with all these formula, all these definitions. I'll talk about all of these terms. I'll talk about the definitions, and I'll also give their formulas if applicable. So if the formulas are there, I will give those formulas. Okay. First, let us actually learn why do we need kinematics and why do we study this chapter especially and its application in real life. Now, assume you have a spaceship and you want to launch it to another planet. Okay, let us say Jupiter. This planet, Jupiter. So, it's not like you'll just launch a rocket upwards and it'll automatically go towards Jupiter. You need some mechanism, and rocket has to follow a certain pathway to reach the planet Jupiter. Okay, correct? Now, you have to direct, see, when you launch the rocket, it will be directing upwards. So, what do you have to do? You have to direct the velocity of the path rocket in this pathway, already dotted path. So basically, what do I mean is that the rocket should travel in the dotted path as shown below. Now, to travel this path, how do you calculate the exact path? It's not just like here you have Jupiter, here you have spaceship, and here you have Jupiter. Just you're drawing a dotted path. Not possible. And how do you design the mechanism of the rocket such that it travels at certain path only? How do you do that? That you are going to be learning with the basics of kinematics, and more precisely you are going to be learning that in something called as projectile motion. Okay, in projectile motion. So in projectile motion you're going to be learning all these concepts. Okay, so basically if you know this distance between the rocket and Jupiter, okay, and this height and this landing place where you want to land, you can calculate even the equation of this path. This path will have some equation because this is a curve. Okay, so you can even calculate the equation of this path. Isn't that interesting? Yes. So this we are going to learn in projectile motion. Now you might ask, if we are going to learn this in projectile motion, why am I telling it over here? It is because the basics of projectile motion is nothing but 1D motion. And that 1D motion we are going to be learning in the first part. And for the basics of 1D motion, we are going to be covering it in this video. Clear? So let us actually deal with some of the basic definitions which are going to be widely used throughout, not only in this chapter, okay, also widely throughout your 11th, 12th, and throughout your life if you take physics. So this is going to be widely used. So first, let us talk about what is distance. Distance is traveled as the length of the total path traveled by the object in a given time interval. Okay, now assume you have a car over here. Okay, now, so car traveled this much distance. Just a second. Yeah. So car is initially over here. Now car went to this path. Okay. It came over here. Next, it came over here. It came over here. And then car came over here. Correct. So this was what starting point P1. And this is what ending point. Okay. I will take it as P. So what path did car travel? from, I will take this as Q1. Okay, it's Q1, Q2. Okay. So how did car go? From P1 to Q1 it travel distance L1 assume. Okay. Then from Q1 to Q2 assume it traveled at a distance L2. And from Q2 to QP2 assume it traveled at a distance L3. So what is distance? What is distance? Distance, what did I tell? It is defined as total length. So here distance is nothing but L1 plus L2 plus L3. So basically from P1 it went to Q1. From Q1 it went to Q2. And from Q2 it went to P2. Correct? So what is the length? From P1 to Q1 it traveled a distance. It traveled a distance L1. From Q1 to Q2 it traveled a distance L2. And from Q2 to P2 it traveled distance L3. And what is the length of the total path it traveled? L1 plus L2 plus L3. So this is what? Total distance traveled. Is this clear? Okay. Now, if this is clear, we'll go with displacement. Okay. Now, the car is starting at point here. So next, car went to this point. Okay. Car went above and car went here. Now, what is displacement? Here it says it is defined as the length of the shortest distance between the starting and ending point. Now, which is the starting point? This is the starting point. And which is the ending point? This is the ending point. Correct? So, what is displacement? Nothing but the distance between the starting and the ending point, which is nothing but the distance between L1 and L2, I mean S and E, which is if you take it as L1, this distance. So here displacement is not the sum of this path plus this path plus this path. If you take it as Q1, take this as Q2. So displacement is not SQ1 plus SQ2, Q1, Q2 plus Q2E. No, no, no. It is nothing. It's just nothing but distance between the starting point and the ending point. So this is L, L2. Okay. Now displacement is what? A vector. Remember, displacement is a vector and it's usually denoted by the letter S like this. Is this clear? The displacement is usually represented by this. Is this clear? What is distance? Distance is a scalar. Displacement, displacement is a vector. Okay, and displacement is represented by the letter S. Clear? Now, what is speed? Speed is nothing but it is defined as distance traveled per unit time, which is nothing but distance. Speed is equal to distance by time. So speed is nothing but distance upon time. Okay. So you can also write it as d distance by time. Okay. And speed is what? A scalar. So speed is a scalar quantity. Is this clear? Okay. What is velocity? Velocity is defined as total displacement per unit time. Velocity, I'll write nothing but displacement per unit time. Okay. So displacement by time is velocity. Now, if displacement is used, what do I tell? Displacement can be written as delta S, and time can be written as delta t, which means assume you have a point A and you have a point B, and car traveled from A to B. So this nothing but delta S, and the time taken for car to move from A to B is nothing but delta T. Now, if the time is small, you can write it in differential form. which is you can write it as ds upon d. Is this clear? Okay. And what is velocity? Velocity is a vector quantity. Velocity is a vector quantity. Remember this thing. Okay. Acceleration. What is acceleration? Acceleration is defined as the rate of change of velocity. So acceleration A. Acceleration is represented by the letter A, and velocity is represented by the letter V. So acceleration you can write it as velocity. You can write it as velocity by time. So acceleration, you can write it as velocity by time. So velocity is nothing but delta v and time delta t. Okay. Now, if the time interval measured is very small, okay, you can write this as in differential form as dv by dt. Okay, clear? Now, there arises one more case. In some of the questions, you will not be given the velocity of the particle, but you will be given the displacement. So, how do you calculate acceleration at that point? Acceleration, you can also write it as d square s upon dt square. So, acceleration can also be written as d square s by dt square. What is d square s by dt square? It's nothing but you will differentiate displacement two times with respect to t. Okay, so displace velocity, sorry, acceleration can also be written as double differentiation of displacement. Okay, is this clear? And acceleration is nothing but a vector quantity. Is this clear? Next, momentum. What is momentum? Momentum is defined as a product of mass and velocity. So momentum is denoted by the letter P, which is equal to m to v. Okay, so momentum is nothing but P is equal to m v. Is this clear? What is v? V is nothing but velocity. M is nothing but mass of the object. M is nothing but mass of the object. Is this clear? Tell me. What is free fall? An object is said to be in free fall when the object is under the influence of gravity alone. What does this mean? Listen to me very carefully. Assume I have a ball. Okay, I have kept it at the top of a building. Someone is holding. Now, without throwing it downwards, okay, assume they just leave it like that. When they just leave it like that, what is the only force which is acting? Have you thrown it with some velocity? No. So it is only under the influence of what? Gravity. Basically, what does this mean is that the acceleration of the ball is g, which is 9.8 meter per second square. So basically, it just means this. The acceleration of the ball is basically equal to gravity. So when is an object said to be in free fall, only the acceleration of the ball is equal to g. Is this clear? Tell me. Next. What is uniform motion? An object is said to be in uniform motion when it travels equal distance in equal time intervals. Correct? Okay. Let us understand this here. You have a car over here. So now car travel some distance, it travel the same distance in same time, again it travel the same distance in same time, again you see. Yeah, correct. So what is it doing? It is traveling equal distances in equal time intervals. Correct. So this car is said to be in uniform motion. Clear? So in uniform motion, basically acceleration is zero. Clear? What is non-uniform motion? An object is said to be in non-uniform motion when it does not travel equal distances in equal time intervals. Now, let us see with the help of this again animation. The car is over here. Yeah. See, you travel first distance in some speed. Next, the next it became slowed. Okay, the car got slowed. Then again it moved fast. Even though the car is traveling equal distances, but it is not traveling at the same time. If you see, right? See, the first part of the distance, it traveled with some medium speed. Next, it slowed down. Next, again, it sped up. So, what's happening is first half distance, assume it's traveled in t1 time. The next half distance, assume it traveled in t2 time. And the next half distance, if you assume it traveled in t3 time, then those times which it covered those distances are not equal. Correct? If you want, I can show you that animation again. So, whenever you get confused by what is non-uniform motion, just remember this animation in your head and you will not get any doubt. And what do you mean by non-uniform motion? Basically, car this car or any object will have some acceleration, and that acceleration is not zero. Remember, the acceleration of the car is not zero. So that is when the car is said to be in non-uniform motion. If this clear, tell me. So with this, I end this video, and the next topic, which is going to be the most important topic, which is going to build the foundation for all the kinematics video and throughout your 2 years, is equations of motion. This is the most basic part which is required. So before watching that video, first make sure all the basic definitions which I've covered in this video are crystal clear. Okay, so with this, I end this video. Thank you for watching. If you have any doubt, let me know in the comments down below. Thank you. Bye bye.